So let us see, in class 20 we discussed about the meter bridge. Now let us see the potentiometer, an important concept, potentiometer. So what is a potentiometer means? A potentiometer is a device which measures EMF very accurately or potential difference without drawing any current. So we can call it as an ideal voltmeter. A potentiometer, we can call it as an ideal voltmeter because it can measure the potential difference or voltage without drawing any current. So the main purpose, what is the potentiometer mean? It's nothing but ideal voltmeter which measures potential difference or potential drop or voltage. Now, what is the principle? The principle behind the potentiometer. Principle, very important one. Principle. What is the principle of potentiometer means? The potential drop across any portion of wire. The potential drop across any portion of wire is directly proportional to length of that portion of wire. The potential drop across any portion of wire is directly proportional to length of that portion of wire, provided a constant current flows through the circuit. It is important one. Provided a constant current flows through the circuit. V proportional to L. The potential drop across any portion of the wire is directly proportional to the length of that portion of wire, provided a constant current flows through the circuit. That is the principle of potentiometer. Now what it contains? It contains basically two circuits, a primary circuit and this is a secondary circuit. This is a primary circuit, this is a secondary circuit. Now it consists of primary circuit consists of a standard cell of EMF E volts whose internal resistance is R. This is, we can call it as a resistance or source resistance RS, a plucky K, a wire of length AB. Wire of length AB. Now what is the length of the wire? AB is equals to LAB is equals to 10 meter. LAB is equals to 10 meter wire. This is a 10 meter wire made up of nichrome. It is a 10 meter wire. Now how this 10 meters connected? So this is A, this is B, this is A, this is B. This 10 meter wire is connected on a wooden slab or wooden sheet. On a wooden sheet with 1 meter, 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 1 attached 10 into 1. 10 into 1 meter gives 10 meters. Okay, these are copper strips. 1 meter and another 1 meter joined by a copper strips are joined by copper strips. So this is AB. This is a magnified picture of AB. In between A and B we have taken 10 meter wire. The 10 meter wire is connected in a process of 10 into 1 meter. Connected by copper strips. This is E and R. This is E and R. RS current. This is a primary circuit brought back. Now secondary circuit consists of a battery, high resistance and a galvanometer and a jockey. Galvanometer and a jockey, as we discussed in the what is jockey we discussed in the last class. Jockey. Now this is the circuit. Now if R is the resistance of 10 meter wire, then resistance per unit length is R by L. That take it as rho. Equation 1. R by L. This L is generally taken as 10 meter. If it changes, then take that length L. Generally it is 10 meter wire only. If you take 500 centimeters, then take L as 500 centimeters. Therefore, the resistance per unit length ohm per centimeter is, or ohm per meter is, R by L is equals to rho. This is in meter we are taking it as lambda. Now taking it as rho. Rho is equals to R by L, the resistance per unit length of the potentiometer wire. Now, what is the current in the primary circuit? The key is on and the current in the primary circuit is Current in the premise I is equals to V is equal to IR. Therefore, I is equals to V by R. That is E by R. That is E by R is here R plus RS. Here this is R plus RS plus R. R plus RS plus R. What is this R? Resistance of the 10 meter wire. What is this R? R is the internal resistance. What is RS? RS is taken as standard resistance or source resistance. I is equals to E by R plus RS plus R is the current through the primary circuit. Current I is equals to. Now again run down the jockey. We can circuit this one primary circuit and run the jockey from A to B at some length. Let us say 560 centimeters or 700 centimeters or 480 centimeters. At some length L, at some length small l, at some length small l, the galvanometer shows zero deflection. At some length small l, the galvanometer shows zero deflection. The galvanometer shows zero deflection. Then in such a case, this is balanced. Circuit is balanced. Circuit is balanced. Now, if this is 1 meter wire, this is 10 meter wire, and this is total length. This is total length 10 meter wire. This is length L, that is equal to, we are taking it as 560 centimeters. Then what is the resistance for this portion of the wire? Resistance for the portion of this wire of length L is R by L into small l. This is resistance per unit length. Resistance per unit length. The resistance for the total 1 meter wire is R by L. Resistance for the unit length of the total wire is R by L. Now then resistance for the length L is, what is this one? R by L into small l. This is, I tell you, this is the cost of 1 fruit. Then cost of 10 fruits is, cost of 1 fruit is 10 rupees. Cost of 6 fruits is 60 rupees. Resistance per unit length is rho. Then resistance for the length L is rho into L. Resistance for the length L is rho into L. Then what is the potential difference? Potential difference is V is equals to current into resistance of that portion of the length. Resistance of portion of wire of length L. Resistance of portion of wire of length L. This implies V is equals to I is E. I take it as we put I into what is resistance of portion of the wire of length L. Resistance per unit length is R by L. Then portion length of wire length L is R by L into L. That is equals to R by L into L. This implies V is equals to I rho L. V is equals to, we can call it as R by L is equals to rho. R by L is equals to rho ohm per centimeter. Therefore, V is equals to I rho L. Here the current, I told in the beginning only, if a constant current flows through the wire, principle is the length of the portion of the potential difference is directly proportional to length of that portion of wire, provided a constant current flows. Current remains constant. Resistance per unit length remains constant. Therefore, this implies V proportional to L. V proportional to L. So, this is the picture of our potential difference across the length and principle. Now, what we have now, V is equals to, instead of I, you can put E by R plus RS plus R into R by L into L. So, this is the putting all the ingredients here. V is equals to E by R plus RS plus R into R by L into L. So this is what is this capital L? Capital L is the total length of the wire between A and B. What is L there? It is the balancing length. Small l is the balancing length. From this equation, V by L is equals to I rho. V by L is equals to I rho. So this, take it as equation 3. This is equation 4. This is equation 5. V by L is equals to I rho. Now what is V by L? V by L is called as potential gradient. V by L is equals to X, the potential gradient. V by L is equals to X, we call it as potential gradient. Therefore, X is equals to I rho by I rho. X is equals to I rho. This implies X is equals to IR by L. X is equals to IR by L. X is equals to I into R by L. Potential gradient V by L is equals to R by I into R by L is potential gradient. Now, a small application to this one now. Small application is, what is small application? Here is, so taken that rho is equals to R by L. Now we have resistance R is equals to SL by A. R is equals to SL by A. S is the specific resistance. We have discussed this in the previous classes. Specific resistance. Specific resistance. Then R is equals to SL by A. L is the length. Length of the wire. A is the pi r square is the area of cross section. Area of cross section. Area of cross section. This implies R by L is equals to S by A, that is equals to rho. R by L is equals to S by A, that is equals to rho. Therefore, you can take R by L replaced with S by A. What is S there? It's not resistance. It is the specific resistance. The specific resistance. Therefore, equation 6 becomes, what is equation 6 becomes now? Now, X is equals to I into R by L, that is equals to I rho. This implies X is equals to I into S by A. This implies X is equals to IS by pi r square. X is equals to IS by pi r square. X is equals to IS by pi r square. This is important one. So R by L can be replaced with S by A. What is S here? S is the specific resistance. A is the area of cross section of the wire, which is pi r square. And therefore, as V is equals to, or V by L is equals to I rho, in place of rho we can write R by L or S by A. Therefore, X is equals to I into R by L or I rho, that is equals to, implies X is equals to IS by A, or X is equal to IS by pi r square. And another application for this one is, let us say two wires are joined. Two wires of resistance R1, length L1, joined to another where the resistance R2 and length L2. Two wires of resistances R1 and R2 and lengths L1 and L2 are joined to form a potentiometer. 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 Then what is X? X is equals to I into R by L. This X is equals to I into I rho. I into R by L. This implies X1 is equals to I R1 by L1. X is equals to I R1 by L1. And X2 is equals to I R2 by L2. I R2 by L2. This implies X1 by X2 is equals to I R1 by L1 into I R2 by L2. I gets cancelled. Implies X1 by X2 is equals to R1 by R2 into L2 by L1. If two wires of resistances R1 and R2 of lengths L1 and L2 are joined to form a potentiometer, then what is the potential gradient? What is X there? X is the potential gradient. Potential per unit length of the wire is potential gradient. V by L. X is equals to V by small l. V by L is equals to X, that is equals to IR by L. IR by L. L is the total length, R is the total resistance of the 10-meter wire. Then X1 is equals to IR1 by L1, X2 is equals to IR2 by L2. Then X1 by X2 is equals to R1 by R2 into L2 by L1. So let us see the comparisons in the next class.